Now we'll look at component form of vectors. So if I have some vector, a comma b, and it can be written in component form, ai plus bj, where I is the horizontal unit vector. So that looks like 1, 0. And if I wanted to graph that, it would just be right here. And the other one is j is the vertical unit vector. So that would look like 0, 1. That one would be right here. Both of these have a length of 1, and they're either going exactly horizontal or exactly vertical. And so what component form is expressing some vector as some scalar multiplication of I plus some scalar multiplication of j, the vertical unit vector. So let's look at this in practice. If I have this vector u, I could write it in component form. So what that means is, let's see, I want some amount of i's plus some amount of j's. Well, how far does u go in the horizontal direction? Well, it looks like u goes 2 units in the horizontal direction, okay, because again, this is u right here, okay, 2 units in the horizontal direction, and then 4 units in the vertical direction. So I would have 2i plus 4j. So how could I think about that? Well, 2i, like if we think about what would 2i look like? Well, 2i would just be this vector down here, right? I'll just do it with my laser piece. It would be 2i would be going all the way from the origin just up to 2. And 4j would be this one, right? It would be 4 times as long as my unit vector, meaning having a length of 1. It would go all the way to 4, but in that same direction. So if I took those two vectors and added them together, so if I took this vector here, which is 2i, and then I took this vector up here, which is 4j, and I added them together, well, how do we add vectors together? We just line them end to end. So 2i, I could line up on top of 4j, and then I see that u, right, u is this one in red here, starts at the beginning where 4j starts and ends at the end where 2i would end. And so that is a way of writing this vector u in component form. So then how could I write this vector v in component form? So let's try that one. So what would v be? Well, if I'm kind of looking at here's where v starts and here's where v ends, how would I think about their combinations of these little unit vectors that are either horizontal or vertical? Okay. Well, if you're just kind of giving v directions to get from the start to the finish, I would say go to the right, in the positive horizontal direction, kind of 2 steps. So 2i, and then if I'm trying to get down this way to its ending point, then I'm going down. So I actually want plus negative 2j or subtract 2j. And that's how I would write those both in component form. So now if I want to calculate u plus v and verify it by the graph, okay, now we're just kind of back to what we were practicing before. Well, I can still use this component form if I want to do it. So here this is using the arrows, and again, we can use the arrows or not, it's the same thing. So u plus v, well, this is really just saying add those horizontal components and add the vertical components together, which is what we were just doing. So the horizontal components for these ones are the same, so it would be 2 plus 2. And then the vertical components for these ones are 4 minus 2. So what do I get for this vector? It is 4i plus 2j. And then I already have u and v lined up end to end, right? So if I look at this, I have u up here, and then v starts where u ends. And so then this vector in black is already going to be u plus v. Okay, well, what's the position vector for u plus v? Well, it starts at the origin, it ends at the point 4 comma 2. So this one should be, u plus v should be 4 comma 2, or in component form, 4i plus 2j. So we feel good about comparing the graph and seeing that it's correct. Now let's look at u minus v. Well, when we did this before, we said one way to think about it is adding the negative, or we could just do straight subtraction. So I'm still going to do it with my i's and my j's here. So for the I, I'm going to take my x values, or sorry, my horizontal component, and I'm going to do 2 minus 2, and then now here I'm going to do 4 minus negative 2. This gives me 0i plus 6j, which is just 6j. Okay, let's clear off some space here with what we were doing and just kind of, oops, I think we wanted that one. And look at u minus v. Well, what would u minus v look like? We already have u right there, so that's good. And then if I wanted to put a v on, well, so if I want to subtract v, right now I have regular v and I want negative v. So if I wanted to connect negative v to where u ends, so here's where u ends, and I want to start negative v there. Well, negative v should have the same length, but be going in the opposite direction. So it should be going, instead of over to, down to, it should be going up to, left to. So where would that end? Well, we gotta kind of cheat a little here and go up, say, let's say our 6 mark is about up here. Okay. Yeah, maybe right there. So then if we add negative v, which would be, say, right here, okay, now I'm starting to get a picture of what I would get if I had u minus v. Well, start with u, where u ends, start negative v, here's negative v, and now what would my resulting vector be? Well, u minus v would start at the beginning of u, it would start at the beginning of u, and it would need to end at the end of negative v. That's all the way up here. And notice that this one is just going straight up. So this is u minus v. It's going straight up. And so 6j, or just 0, comma 6, is the correct vector. And we verified that graphically.